Today's topic is integrated rate law for first order reaction. A first order reaction is the one in which the rate is directly proportional to the first power of the molar concentration of the reactant. Let us consider a first order reaction where R gives some product. So by rate law we can write the rate of this reaction as rate is equal to K into molar concentration of the reactant raised to the power of 1, where K is called as the rate constant. Let us call this equation as equation number 1. Next, rate is defined by definition we can write the rate expression as rate is equal to minus d r by dt. So from equation 1 and 2 we can write minus dr by dt is equal to K into molar concentration of R. Now rearranging the terms we get dr by R is equal to minus K dt. Now let us integrate this expression on both sides. So on integration we get integration of d r by r is equal to integration of minus k dt. Now this one step you must remember, the integration of 1 by x dx is log base e x. Log base e can also be written as ln x, ln. Okay, now this is also of the form 1 by r dr. See, 1 by x dx, integration of 1 by x dx is log base ex or ln x. In the same way, integration of 1 by r with respect to dr is ln r. This is equal to integration of minus k dt is minus kt plus c, where c is called as the integration constant. Now we have to find the value of c, that is at t is equal to 0 we know this r is equal to r0. What is this? This is molar concentration of the reactant after a certain time interval. What is this R0? This is the initial molar concentration of the reactant. Now substituting this in this equation we get ln R is R0. This is equal to minus K into T is 0 plus C. So we get ln R0 is equal to minus K into 0 is 0 plus C. So substituting the value of C in this equation we get ln R is equal to minus KT. The value of C is ln R0. Now we can write KT is equal to ln R0 minus ln R, minus ln R. And we all know that log m minus log n is equal to log m by n. So we can write this as KT is equal to ln of R0 by R, or K is equal to 1 by T ln R0 by R. Now to convert log base E to log base 10, Log base e is natural logarithm. Log base 10 is the common logarithm. So to convert log base e to log base 10, we must multiply 2.303. So let us convert this log base e to log base 10. So we get k is equal to 2.303 by t log of r naught by r. This is the common logarithm, that is log base 10. This is log base e. To convert log base e to log base 10, we must multiply 2.303, and this is the expression for the rate constant of a first order reaction. Is this clear? Once again I will repeat. You must consider a first order reaction and you must write the expression with respect to the rate law and by the definition, and from these two equations we write this, and by rearranging the term we get this expression, and next we must integrate this. On integration we get this. Here where c is called as the integration constant. To find the value of c, we take t is equal to 0, r is equal to r naught. Substituting this in the equation we get this. Finally we get the value of c. Substitute the value of c in this expression, so we get this. Now we must find an expression for k, so we take minus kt to the left hand side, which becomes plus kt. This plus ln r, when it goes to the right hand side, becomes minus ln r. This is log m minus log n is log m by n. Then we write k is equal to 1 by t ln of r naught by r. So to convert ln to common logarithm, we multiply 2.303. So this is the expression for the rate constant of a first order reaction, where k is the rate constant, t is the time, r naught is the initial molar concentration of the reactant. This is the concentration of the reactant after a certain time t. Okay. Now let us draw few graphs related to the first order reactions. Okay. First, let us start with this expression. Look at this expression. This expression is of the form y is equal to mx plus c. Here ln r is y, so you have to plot ln r along y axis, and here t is x, so along x axis you must take time. Then if you plot a graph of ln r versus t, you see, since the slope is negative minus k and there is a y intercept, therefore since the slope is negative and there is a y intercept, the graph will be like this. The graph is like this, and this gives you the y intercept. And what is the y intercept? Y intercept is ln r naught is the y intercept, and what is the slope? Slope is minus k. So this is very important. You must know all these graphs. Okay, in the competitive examinations they give a graph and they will ask what is the y intercept or what is the slope. Okay, so you must remember all these graphs. It's very important. Next, let us take this expression. If I take this expression and if I consider this to be y and this is x and this is m, so y is equal to mx, so there is no y intercept, slope is positive. So if you plot a graph of ln r naught by r versus ln r naught by r versus time, we get a straight line starting from the origin having a positive slope. So what is the slope? Slope is equal to k. In this case, slope is equal to k, the rate constant. And what is the y intercept here? Y intercept is 0. So this is one graph, this is the other graph. Next, one more graph is there. Let us take this expression. We will just modify this expression. We will take t here. So we get kt is equal to, this 2.303 will come to the denominator. So 2.303 is equal to log r naught by r. Okay. Now Let us take this as y, that is along the y axis. Let us plot log r naught by r, and this will give you the slope, and this is x, this is slope. So y is equal to mx. Now if you plot a graph by taking log of r naught by r along y axis and time along x axis, since the y intercept is 0 and slope is positive, you get a graph that is a straight line starting from the origin, and here the y intercept is 0. And what is the slope? Slope is k by 2.303. so this is the slope in this case. Okay, so these are the three important graphs that is related to first order reactions. Okay, once you go through this, I will write the derivation part for you. You can just copy down and study this. Okay, this is all for today's class.